In this video, we will discuss about Pascal's law, or also called Pascal's principle. According to Pascal's law, whenever an external static pressure applied on any part of fluid contained in vessel, the pressure is transmitted evenly throughout the liquid in all directions. Pascal's law formula shows the relationship between pressure, force applied, and area of contact. Hydraulic power machines works on the basis of this law. For example, in hydraulic lift, as shown in figure, two pistons are separated by the space filled with a liquid. A piston of small cross-section area represents as A is used to exert a force, capital F, directly on the liquid. The pressure is transmitted throughout the liquid to the larger cylinder attached with the larger piston of area B, which results in upward force, which is pressure multiplied with area of contact, capital B. Therefore, the piston is capable of supporting large force, that is large weight of car placed on the platform. By changing the force at the area A, the platform can be moved up or down. Thus the applied force has been increased by factor B upon A, and this factor is mechanical advantage of the device. Next we will see the complete derivation of Pascal's law. Let us consider an arbitrary right-angled prismatic triangle in the liquid of density rho. Here prismatic element is very small, in which every point is considered to be at same depth as the liquid surface. Therefore, the effect of gravity is also the same at all these points. Let EH, FH and GH be the areas of the face PQTU, PQRS and SRTU respectively. Let P1, P2 and P3 be the pressures. The pressure exerts a force which is normal to surface. Let P1 exert force F1 on the surface PQTU and P2 exert force F2 on the surface PQRS and P3 exerts force F3 on the surface SRTU. Therefore, force F1 is given as P1 into area of face PQTU, that is G into H, and force F2 is given as pressure P2 into area of face PQRS, that is F into H, and force F3 is given as pressure P3 into area of face SRTU, that is E into H. Also trigonometric ratio for sin theta will be opposite side, that is F upon hypotenuse side, that is small g, and trigonometric ratio for cos theta will be adjacent side, that is small e, upon hypotenuse side, that is small g. The net force on prismatic element will be 0 since prismatic element is in equilibrium. Therefore, we can write F1 sin theta equal to F2 and F1 cos theta equal to F3, where F1 equal to pressure P1 multiplied with area PQTU, that is G into H, and F2 equal to pressure P2 multiplied with area of face PQRS, which is F into H, and F3 equal to pressure P3 multiplied with area of face SRTU, which is E into H. And from equation 1 and 2, trigonometric ratio for sin theta and trigonometric ratio for cos theta. So I'll substitute all these terms in equation 3 and 4, and after simplifying equation 3, we will get P1 equal to P2, and after simplifying equation 4, we will get equation P1 equal to P3. Therefore, I can write P1 equal to P2 equal to P3, where P1 equal to F upon GH and P2 equal to F2 upon FH and P3 equal to F3 upon EH. It means pressure exerted is the same in all directions in the fluid which is at rest.